So we're going to start on a fundamental level, and cells are the fundamental component of every living thing, and DNA makes up the chemical coding that directs their construction and development and operation. What that means, like, DNA controls everything pretty much in our body and how things work. As an organism's entire DNA sequence is known as its genome, in which consists of 3 million base pairs. A cell does not read the base pairs as one long stream. It reads the base pairs as individual segments or words. And each segment provides instruction to the cell for doing what the DNA sequence told it to do, like either going to be a respiratory or lung cell or going to be a liver cell. That's where the DNA sequence comes in, and that's when the cells mature into what cell they're going to be specifically. Genes also have their say, but it's not necessarily the final say on how a person turns out, for he or she is also affected by incredibly complex interactions between genetic systems and environmental factors. So what the DNA says in the genome doesn't technically mean that that's how the cells are going to be for the rest of their life. They could change over time, or environmental factors could come into play and change them as well. Also, there are some mistakes that happen with the DNA sequence. Mistakes can include mutations or alterations, and they can arise when the orders of the DNA sequence are wrong, or when the base pairs are added, duplicated, or deleted. And with that being said, we know a lot of problems that arise in humans when the DNA sequence or the genome is messed up in some type of way, and that's when diseases happen or other changes in the body happen. So some genetic mutations are acquired, which means they happen in people randomly or because of the exposure to some agents such as radiation, chemicals, or cigarette smoke. Like COPD, you get it from cigarette smoke, or cancer. If cancer treatments, if you're getting radiation, it could cause like a rash, or it could cause some other problems. But mutations can also happen indeed hereditarily and are transmitted through families and triggering the same genetic disease in generations. And we all know that you get stuff passed down from your mom and dad, and that's how diseases are transmitted hereditarily. Now, with advancements in genetics over time, it is now possible for scientists to check for genetic disorders by looking at the changes in a person's DNA. And they can do this from a multitude of tests, and I'm going to explain some of the tests that the book talked about. And all the information that I have explained is from our Lewis textbook, Bioethics. And some of the genetic testing includes newborn screening, which can be used to uncover genetic diseases for early treatment. A carrier testing, which is used to determine whether someone is a carrier of a certain type of genetic disorder. Predictive testing is used to find out if someone is likely to develop a genetic disease later in life. Diagnostic testing is used to confirm or rule out a genetic disorder in someone with symptoms. And then another one is prenatal testing, which they can to determine in a fetus before it is even born if it has any genetic abnormalities. And the last one is pre-implantation genetic diagnosis, or PGD, which is used to test embryos produced in IVF, which we talked about in our presentation a couple weeks ago. And within IVF, they check for genetic abnormalities as well. Now, with all of these genetic advancements and genetic testings that come along with it, there are some very big ethical concerns. And in the book, it talks about a lot of different ones, but I'm just going to talk about a few of them that stood out to me as really big ethical concerns. So the first one is genetic testing itself is laden with complications that erode its usefulness and provoke medical and moral questions. For one thing, genetic testing almost never yields conclusive answers. So even when you do a genetic testing, you don't always get the answers that you need. And even when you get a positive result for an identification of a mutation, that does not always guarantee that you will develop the genetic disorder. So even doing the testing and getting the positive result, you may never even develop the disorder. So that's one of the big ethical concerns, is that you just never know definitively if you're going to develop this genetic condition or not. Another ethical concern is the knowledge is not a blessing, but it could be a curse. And this means that with genetic testing, many times when they find the abnormality or the disease that they may develop later in life, there may not be a way to treat it and there may not be a way to help them. So, like they said, knowledge is not a blessing, it is a curse. Meaning that even though you know this knowledge about any genetic abnormalities or genetic disorders that you may have in the future, it might not be better for you to know, because we may not be able to help you with some diseases. Like, I know early onset Alzheimer's is a genetic disorder that you can get genetic testing for, and even knowing that earlier than it was going to develop in your body doesn't really help you, because there's no treatment that can really help you. So that's one of the big ethical concerns, is this even good enough for people when we may not even be able to help them. And the last ethical concern I'm going to talk about is that with this genetic testing, it can take an emotional toll, not just on the patient, but it can also take an emotional toll on their families as well. After getting the test results, a lot of the patients feel angry and depressed or frightened, and even if the test is negative, and they could develop a vulnerability of knowing that they may not get this disease, even though they can be certain that they won't even get it. Either way, they may ignore the opportunities to lower risk, or they can make choices that could worsen their behavior and make it even more likely that they will develop this. So I think they just need genetic testing as a whole just needs to be developed more, because it can definitely put a strain on the patients and not provide a positive outlook all the time. I mean, it's a good thing, because sometimes you want to know some diseases if there's a way that you can treat it, but with diseases that you can't really treat, I think it could just cause more problems than help.
So the National Institute of Health, they describe stem cells as cells that have the potential to develop into multiple different cells in the human body. These cells are most commonly taken from embryos and adults, though the University of Nebraska Medical Center, they say that adult cells are very difficult to find and multiply, unlike embryonic cells, which are extremely easy to find. They can multiply really quickly and they can be stored for long periods of time. So the preferred method to get stem cells is through embryonic extraction. So some ethical concerns related to stem cell research are the University of Nebraska Medical Center. They have two really good ethical concerns listed in reference to stem cells being taken from embryonic or embryos. So the first one that they highlight is to gather enough cell mass from an embryo, the embryo itself is destroyed. So this is troublesome because embryos are living organisms and ultimately they're being killed. So that's a major concern because it's taking away the potential of life through that embryo. Another major concern, especially related to the medical ethics class, the embryo's consent is never taken into account, and they cannot give consent. So therefore, their well-being and their potential of life is not being taken into account. There's also concern related to the consent of the woman who may be donating the embryo. If she is unaware that the embryo is being taken to be used for research, that can be a major consent problem.
For the stance of stem cell research, we will utilize the theories of natural law theory and Kantian ethics. First, in natural law theory, right actions are those that conform to moral standards discerned in nature through human reason. This theory says that something is good if it is natural, and badness is seen as going against a natural purpose. By looking at the theistic formulation of Thomas Aquinas under natural law theory, we can argue that human beings naturally tend toward, and therefore have a duty of, preserving human life and health and producing and raising children, which embryonic stem cell research goes against. If we also look at the doctrine of double effect under natural law theory, we can say that it is always wrong to intentionally perform a bad action to produce a good effect. So when you view the embryo as a person, even killing the embryo, which is a bad action, to produce a good effect, which would be providing stem cells, is not morally permissible. Therefore, under natural law theory, research using stem cells derived from embryos would be considered immoral because it involves destroying innocent human life. Under Kantian ethics, if the embryo is considered a person, then destroying it after genetic testing is impermissible. The categorical imperative says that persons must be treated as ends rather than means. By defining it as categorical, it applies without exception and without regard for particular needs or purposes. By using an embryo to save lives, even though it may be for a good cause, the embryo is still being used as a means to an end, specifically the end of certain diseases. Because it's a categorical imperative, the exception of using embryonic stem cells is not justified through the benefit of research. By doing this, you are not considering the impact on the person or the embryo and are using them to pursue your own means. Therefore, under Kantian ethics, stem cell research is not morally permissible.
So we'll start with everybody's favorite autonomy, which is a person's rational capacity for self-governance or self-determination, also the ability to direct one's own life and choose for yourself. So Jamie kind of mentioned this, but one of the biggest arguments as to how stem cell research violates autonomy is the potential for life argument. So by using, say, an embryo for stem cell research, we're not giving that embryo even the option to become an autonomous human being. So while an embryo itself might not be autonomous, it again has that potential to be autonomous. Additionally, we're using someone's own bodily product. We're using something that is someone's own DNA, something they created with their own body, and it brings into issues of consent. So with stem cell research, there is the potential for a lack of informed consent. According to an article from the Endocrine Review Journal in 2009, authors Lowe and Parham mentioned that some people might consent to the use of their gametes for childbearing, but not research. So it's really important that people understand an informed consent form and basically what they're agreeing to. Again, when it comes to oocyte donation, which is a female's gametes or a female's reproductive cells, the major problem is whether or not participants actually understand the details of informed consent. So again, people have a right to know exactly what they signed up for, especially when their DNA is at stake. Additionally, in some cases, consent can even be waived. According to the same article, in the United States, federal regulations on research permit a waiver of informed consent for the research use of de-identified biological materials that cannot be linked to donors. Thus, logistically, it would be possible to carry out embryo and stem cell research on de-identified materials without consent. Basically, this research could be done without one's consent. Next, we'll discuss justice, which refers to people getting what is fair. Now, again, that lack of consent is extremely unfair to donors and participants alike, but also, according to the Hastings Center in 2005, the National Academy of Sciences established guidelines for the conduct of human embryonic stem cell research. Now, while these guidelines are widely accepted and adhered to by many universities and research clinics alike, they are merely voluntary. So there are organizations out there that don't adhere to those guidelines, and it puts patients at risk. So this means if something were to happen, if they didn't understand conformed consent, they might not get proper representation. Their embryos or gametes or what have you could be used in a way that they did not agree to, and that is certainly an unjust practice. Next, we'll discuss beneficence, which is actively promoting good for others. Now, you can't say that stem cell research is a beneficent practice if it doesn't adhere to the first two. So if it violates someone's autonomy and it's an unjust practice, it's simply not promoting good. Additionally, if someone is only looking out for themselves, they're not actively promoting good for others. So in some cases, doctors and clinicians are being compensated in kind of shady manners or coercing their patients into allowing this research without informed consent. According to the Hastings Center, stem cell-based therapies are only the standard form of care for a very few amount of conditions. So stem cell therapy is not a widespread practice, but there is an increase in stem cell tourism. So in this case, there are greedy doctors and clinicians around the world kind of preying on people for large sums of money, telling them that there are effective stem cell therapies for all kinds of conditions. These clinics are trying to advance their claims without credible scientific rationale, transparency, oversight, or patient protections. So this isn't promoting good for people, they're monetizing on it, and they're not protecting their patients, which is not promoting good for others. Which also brings us to the next idea of non-maleficence, which says to not inflict harm on others intentionally or unintentionally. Again, according to the article from Endocrine Review in 2009, the authors say that the medical risks of oocyte retrieval include ovarian hyperstimulation syndrome, bleeding, infection, and complications of anesthesia. So a lot of physical harm can be done in the process of stem cell research. Again, according to the Hastings Center, along those same lines as the stem cell therapies, the unproven stem cell interventions outside of carefully regulated research protocols endangers patients and jeopardizes the legitimate process of translational stem cell scientific research. Patients who travel for unproven stem cell therapies put themselves at risk of physical and financial harm. So not only can these patients be physically harmed, but also financially harmed due to the cost of travel and getting this treatment that isn't even legitimate. Finally, we have utility, which is producing more favorable good over bad for all people. According to the Hastings Center, the potential for over-commercialization and restrictive patenting practices is a major problem facing stem cell research today. It may delay or reduce broad public benefit of stem cell research. So, this says that physicians, as in the case of stem cell therapies, and that monetization is more personal, it's a monetary benefit, rather than promoting the greater good for all people. So rather than sharing their knowledge with other scientists and doctors, they're keeping it to themselves for monetary gain, fame, success, and not helping others. And in this way, they're using stem cell research as a means to an end, which, as mentioned by Catherine, directly violates Kantian ethics.